Hello everyone, welcome to the Production Institute YouTube channel again. I want to thank everybody for subscribing to my channel. I really appreciate it. Today we're going to look at how to repair an XLR or how to make an XLR and some of the issues that go along with that. We're going to examine how the soldering is done, first of all, to make sure that you have a correct solder joint rather than a cold solder joint or a dry solder joint. And there's some technique involved in there, and you can visually identify these things, as we'll see in a few minutes. But also another common problem when just repairing cables is that often a cable can be put out of phase simply by reversing two of the conductors accidentally. And I'll show you why that happens. And so let's get started here and zoom in on this tightly on this XLR setup that I have here in my helping hand setup. Let's take a look. Okay, as you can see then, I've got three wires. The shield on pin 1 and pins 2 and 3 carry the balanced signal. Pin 1 and the shield are there to remove any RF pollution from the signal that's being carried between these two conductors. And what's important about this is that the signal is split into the high half of the waveform and the lower half of the waveform, or vice versa, depending on which is hot in your system, which pin is being used as the hot pin, that is. In the US and internationally, generally speaking, pin 2 is now considered to be the hot or high leg of the signal, which would carry the upper half of the waveform, and pin 3 is carrying the lower half of the waveform. So if you reverse these two on one end of the connector, then what you have is an out of phase signal. You've reversed the phase of the signal, and now the pins are carrying the opposite of what they are from one end to the other. And in a situation where you have a stereo microphone or a stereo DI, were you to use this reversed situation on one cable, you're going to get phase cancellation. And in fact, most of the time you'll get almost 100% phase cancellation. If you push up the fader and it's panned straight up into the center on channel 1 and it has a normal cable, you'll get a normal sound out of it. Then as you push up channel 2, it will start canceling out because these two pins are reverse, and the reversal of the waveform will literally cancel the first channel out, and your signal level will disappear from both channels. You'll get no sound. And this is a common error that's made, say when somebody when one end of the cable, one end or the other, is damaged either by handling it or somebody pulls on it too hard or what have you, or there's a cold solder joint or a dry solder joint in one end and it needs to be repaired. And what will happen is somebody will take just one end of the cable off to repair the cable, the end that's broken or they suspect is having a problem, and they'll mix up which pins are connected, which color wires are connected to which pin. So again, when that happens, you're going to get phase cancellation. Now, if all of these cables are wired exactly the same, that can never happen. All it takes is one, though, out of phase, and it can cause some pretty serious problems, depending on where it ends up in your signal path. You won't always notice an out of phase cable, but there's several situations where you could, especially if you're using two cables in a stereo format. You have a stereo microphone or a stereo DI or something along those lines, and you push up both faders at the same time with equal amounts of gain on the channel, and with one cable out of phase, they will phase cancel each other out. And I mean, they will really cancel each other out. There'll be nothing once you push them up equally. So again, let's take a look here. We've got our drain wire on pin 1. In this case, we've got the low side of the signal on pin 3 and the high side of the signal on pin 2. And pin 2 is the international standard for the high side or the hot side of the signal, and pin 3 is the low side of the signal. So it's common to make this error of reversal because when you look at these, they look the same, generally speaking. But if you think about this, you see you have to rotate these in space in order for them to connect to each other. So if you take a look at this from the back side, the female from the back side, you see that pin 1 is on the right hand side. But if you rotate this around and look at the male, the back of the male side, pin 1 is on the left hand side. So when you're soldering these, you have to remember that pin 1 and pin 2 reverse their positions between a male and a female connector. And so it's very important to reverse the wires. Make sure that pin 2 and pin 1 don't get reversed, because this will also reverse the phase of your cable. Any reversal of these 3 wires in the wrong order will create an out-of-phase cable. So the upshot of this situation is to be very careful when you're working on the XLRs, on the back side of the XLR where the solder cups are, because like I said, because you have to rotate those in space when you're working on them from the back side, it reverses pin 1 and pin 2 compared to male and female XLR connectors. And it's just very important to keep track of that. And so if you have a big pile of cables to fix, or you're making cables, it's easy enough to get distracted and simply wire one backwards because you're just trying to move quickly and get the job done or what have you. And so my suggestion there is to go slowly, and you can also write down exactly what you're doing, so you can refer back to, like, get a 3x5 card and write down, pin 1 is the shield. Naturally, it's always the shield. Never is pin 1 to be anything but the shield. And then pin 2 would be, in that case, the white wire, and pin 3 the black wire. And simply write those down so that you glance at them once in a while to remember. And the other suggestion I was going to make is that if you're making cables, that you make only one end at a time. In other words, you start with raw cable, and you start with raw connectors, and you do all of the females first. And if you're making, say, 10 cables or a dozen cables or something, you focus on just the female ends, and that way you're less likely to make a mistake if you're flip-flopping back and forth. And then once you get all the female ends on, you start soldering on the male ends, and remember to reverse the position of 1 and 2 as far as the wires are concerned. And again, because you're doing them all right in a row, there'll be less chance of you mixing them up instead of making one end and then flipping over to the other end. That's my method anyway. So in this next video, I'm going to show you how to add solder to the cups, how to tin the wire, and then how to connect the two together with your soldering iron, how to properly leave a solid solder joint that is not either a cold solder joint or a dry solder joint, the two most common mistakes that are made when soldering. So stay tuned for that. That's coming up next. And thanks again for all the subscriptions, folks. Really appreciate it.